Hello everyone. This video I'm going to show you a projectile motion example from a textbook. Here is the problem. Okay, it says that there is a guy. Let me use my pen here. It says there's a guy on here. He want to toss a ball, pass through the barrier to here, and his angle, his initial velocity has an angle with respect to horizontal axis with 35 degrees. And the first question he wants to ask is the what's the magnitude of the initial velocity? Okay, because he want to pass the barrier, he need a minimum velocity to pass the barrier. Okay, if the velocity is not big enough, he will drop before the barrier. Okay, he want to pass through the barrier. And here is the geometrical information. His hand is his hand is 1 meter above the ground, and the barrier is overall 2.6 meter above the ground, and the barrier is 3.1 meter away from the thrower. Okay, so that's pretty much about all the information. Okay, so how to solve the problem, projectile motion problem? Like I said, we don't really need much about the formula in textbook. We just write down the equation of motion. Okay, x direction. V I x t plus 1 over a x t squared. And the y direction, I think you already know this a lot. A y t squared. Okay. So, I should clean this up. Okay. So let's put us what we have, what information we have. Okay. So the problem want to say what's the minimum velocity for passing this barrier. Okay. So let's make an assumption. Let's we give if we time t, we reach this barrier point. Time t when the object reach this point, when the time is t, it reach this point, reach the critical point. So we write down all the information we have. Okay, so the coordinate is set up here. Okay, on the hand of the thrower. And positive x, positive y. So the ball, the final position of x component is, you look at this picture, is clear. The final here is at this point t, and when the time is t, the point here is x component is 3.1. So let's write down 3.1 equal to initial position. Okay, its origin is here. Okay, origin is here, so it's 0. And the v cosine is x component of velocity, so it's v cosine 35 degrees. And the time we don't know. And plus 1 over 2. And the acceleration x direction, because the projectile motion which only have the acceleration in y direction. So it's 0. So we can ignore this. Okay, we don't have to consider this. So it's pretty good. We don't have write many terms. So the y direction here, at point t, the y direction, the position of y is 1.6. Be careful, because the coordinate origin is here. So it's 1.6, not 2.6, because we set origin here. Right, 1.6. And initial position of y is 0. So the initial velocity of y is v sine 35 degree and times t, and plus 1 over 2. The AY acceleration y direction is minus 9.8. Be careful the negative sign, because the acceleration is point downward. And this coordinate, the downward, is negative. So be careful with this. And square. So we will have two equations. Okay. we have two unknown and two equations, so we definitely can solve it. Okay, v we don't know, t we also don't know because we really don't know the t, and 1.6 equal to v sine 35 degree times t minus 4.9 t squared. So for this two equation, how do we solve that? Actually, it's pretty simple. We just and we can use this. We can. How do we know it? Which one is better? Let me see. If we'll replace v is better. Let's see. Let's just say from equation 1 we have v equal to how to say v equal to t cosine 35 degree. That's pretty much easier. 3.1. Okay. 3.1 over t times cosine 35 degree. That's v. So you plug in the equation, what will we get? Pretty good. So we will have 1.6 equal to v sine. Oh, sorry. What will we have to get? We have a v. Okay, v is 3.1 over t cosine 35 degree, and times sine 35 degree, and times t minus 4.9 t squared. Okay. Okay. So what can we eliminate? This can be Q, and we will have 1.6 equals 25 times tangent 35 degree minus 4.9 t squared. So we will get what's the answer? So we will get, I'm not sure it's easy to get 4.9 t squared equal to 3.1 tangent 35 degree minus 1.6. It's equal to, I'm not sure my answer is right. Times tangent 35. Sorry, 5.1 times tangent 35. Minus 1.6 and divided by 4.9 in the square root 0.34. Anyone agree with that? 0.34. Okay, 0.34. Okay. So that means after 0.34, the object reached this point. But that's not the first question we want to answer. First answer is minimum velocity of v. But since we have 0.34, so we just plug back into this equation. So, and you will get the 3.1 equal to v cosine 35 degree times 0.34. So you will get your initial velocity. It should be 11.13. 11.13. Okay, so that's the first question. First problem. The first question. The answer of first question, what's the minimum speed to pass through the barrier, is 11.13. Okay, the second question is how far it will reach. Okay, how far object will reach. You want to, okay, how far it will reach. For example, you want to find out, let me turn off this screen. Okay, how far it will reach. Okay, you want to ask this distance. Okay, how far it will reach. Okay, so since the screen now is very complicated, Okay, sure. Okay, let's just stop a video here, and I will show you the second problem in the next video. I think it's more proper. Okay. Okay, so see you in the next video. Bye bye. Bye 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 bye. That's easy to make video. Short.